Okay, so in this problem they want us to find the vertical asymptote of logarithmic function. So that's the question. What is the vertical asymptote of, and they give us this, function with all kinds of things going on. Well, it's really going to be based on what the domain is, right? So remember at the very beginning of this section we talked about, well, x plus 4 has to be greater than 0, so x has to be greater than negative 4. Okay, that means my vertical asymptote is at negative 4. So I can draw that in. And I can say, they asked me what the vertical asymptote is. Okay, so asymptote x equals negative 4. And I'm done with this problem. But I thought it might be interesting to you. You might be wondering, well, what if I had to graph this? Now, I'm not saying you necessarily will have to graph one like this, but I thought it might be interesting to kind of look at it. Okay, so we would go to the parent function first. So I'm going to graph g of x equals log base 3 of x. And I'm going to think about what that is. Well, that has a vertical asymptote here. It's going to have an x-intercept at 1, 0. And then it's also going to have a point, the key point, 3, 1. And it's going to look something like this, right? Okay, now what are all these transformations going to do to it? Well, I can make a table of values here. So we'll do a little table of values. I'm not going to do a big one. And let's have, let's say we put in negative 1, 0, and 1. And so we had 1/3, 1, and 3. That would have been for the parent function. Okay. Now let's go over here, whoops, and think about f of x. Well, it all has to do with this, right? Everything's shifting to the left 4 units. My asymptote, I already drew that. That shifted over 4. So now I would have to take the 1/3 and shift it over 4. So what would that be like? Negative 3 2/3, which I don't even want to write negative 3 2/3, but that's what I'll write. Okay, and then the output isn't going to be negative 1. It would be negative 1 times negative 2, which is going to be 2 plus 5, which would give me the 7. So I don't know if you can follow that, but think about, I'll just write this one out. I remember this is kind of all extra work. It wasn't really part of this problem. They don't even give you a picture in the book. But I'll show you this one, how it's working. So if I put it in the function, I get negative 2 log base 3 of 1/3. Let's see. Yeah, 1/3, okay, plus 5. Now we know this part from the parent function is negative 1. And then you get 2 plus, oops, that's a 5. 2 plus 5, and that's where the 7 came from. Okay? So now if I wanted to get a 1, what would I have to put in for x? Well, I've got to back it up 4. And so that's going to put me at negative 3, which is going to get me 0. 0 times negative 2 is 0 plus 5. So that gets everything in that I need. And then if I put in 3, I would get, I'm sorry, if I wanted to get a 3, I'd have to put in negative 1. So I'm backing it up. And then that would give me 1 times negative 2, which would be negative 2 plus 5, which would give me 3. You can write all of that out like I did over here. Now let's see what those points look like. Negative 3 2/3, and I'm way down at 7. So, I'm sorry, way up at 7. So it's like up there. And then I'm at negative 3, 5. 1, 2, 3, 4, 5. Nah. 5. 5. And then I'm at negative 1, 3. So it's looking like this. And does that do everything we thought it would? You know, did it reflect about the x-axis. You can kind of see that. It shifted to the left 4 units, and the whole thing shifted up 5. And it does seem to have a little bit of a stretch to it, okay? So they didn't ask you to graph it. I just thought I would show that. So sorry for the long video.